Welcome back to my channel. LLMs have transformed AI interactions, but they often produce errors such as hallucination, flawed code, or toxic content without validating their outputs. What if LLMs can correct themselves when they go wrong? Enter CRITIC, a framework that enables LLMs to self-correct by engaging with external tools. Stay tuned to discover how CRITIC is setting a new standard on smarter AI. Here's how CRITIC works. First, Black Box LLM generates an initial output based on the input. It then interacts with external tools to verify this output. Feedback, or critiques, from these tools are used to refine the response. This iterative process ensures continuous improvement. The model first generates an initial output y0 hat based on the prompt and the input x. Think of this as the model's first guess. The output yi hat is checked using external tools T through API calls, and the API call results are then concatenated with model-generated query to construct the critiques on various attributes such as truthfulness, feasibility, or safety. If the critiques indicate the output is correct, stop the process and return the current output yi hat. If the critiques indicate the output is incorrect, the model then combines the critiques together with the original prompt, input, and previous output to generate a new and improved output yi+1 hat. The loop repeats the verify and correct steps until the output is verified as correct or the maximum number of iterations is reached. CRITIC is tested on question answering, math, and toxicity reduction. They test the method on Text DaVinci 003, ChatGPT 3.5 Turbo, and Llama 2. The researchers use chain of thoughts prompting to produce an initial answer. They build a web search tool based on Google instead of task-specific retrievers to prevent overfitting. Each response is critiqued and corrected up to 3 times. Datasets include AmbiGenQ, Trivia QA, and Hotpot QA. The results are reported in terms of EM and F1 scores. The baselines include vanilla few-shot prompting, chain of thought prompting, self-consistency, and ReACT, which is a retrieval-augmented method. The researchers tweaked these methods for ablation study. For example, the ReACT to CRITIC method uses ReACT to generate the initial result. CRITIC without tool removes the tool calls and uses only the LLMs to generate evidence without changing the prompt. Other baselines such as rejection sampling are also included in this study. CRITIC significantly outperforms all baselines across all datasets on DaVinci and ChatGPT. Yet, CRITIC only outperforms on AmbiGenQ dataset when it is applied on Llama 2. The fact that CRITIC outperforms rejection sampling highlights that CRITIC not only pinpoints errors, but also provides actionable suggestions, guiding the new generation to avoid similar errors. Also, the study demonstrated that tool calls play a critical role, as CRITIC without tool contributes marginal improvement and even falls short compared to the initial output. In math, the researchers use program of thought to produce an initial program y hat that, when executed, solves a problem description X. They use a Python interpreter to generate error messages and execution results. Each y hat is critiqued and corrected up to 4 times. Datasets include GSM-8K, SVAMPT, and TabMWP. The final outputs are compared with the ground truth. The EM score is reported as the result. The baselines include vanilla few-shot prompting and program of thought, which is a state-of-the-art method that writes programs to solve problems. Similar to Q&A, CRITIC without tool is also included as the ablation study. CRITIC consistently outperforms baselines across different datasets on all LLMs. The result also demonstrates that CRITIC possesses excellent scaling capabilities. Without feedback from external tools, the ability of LLMs to correct programs becomes limited or deteriorated. And in toxicity reduction, 1,000 prompts are randomly sampled from real toxicity prompts. The researchers use perspective to obtain fine-grained toxicity information. This API provides scores for 6 different attributes and generates the critique such as, the text has 39% toxicity of insult. Maximum iterations is 4, and terminate the detoxification when the overall toxicity falls below 10%. The toxicity reduction is conducted on text, DaVinci 003 and ChatGPT. Baselines include several existing methods such as PPLM. The results demonstrate that CRITIC substantially lowers the occurrence of toxic generations, while preserving fluency and diversity. Similarly, CRITIC without tool contributes marginally to the toxicity reduction, underscoring the importance of external feedback in detoxification. Overall, CRITIC achieved a 7.7 F1 score improvement in question answering, delivered a 7% boost in mathematical reasoning, and reduced toxicity by a remarkable 79.2%. CRITIC enables LLMs to validate their knowledge and improve their answers without further training, but it's not without challenges. The reliance on external tools incurs latency. Also, different prompt construction and tasks such as translation should be explored. If you found this video inspiring, don't forget to give it a thumbs up and subscribe to the channel. Thanks for watching, and we will see you in the next video.